This is SpaceTime, Series 27, Episode 116, for broadcast on the 25th of September 2024. Coming up on SpaceTime, discovery of more black holes than expected in the early universe, a new volcano spotted on Jupiter's moon Io, and confirming the mass of the W boson. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study using the Hubble Space Telescope has discovered far more supermassive black holes in the early universe than was expected. The findings, reported in the Astrophysical Journal Letters, will help astronomers better understand how these ancient black holes were created. See, currently, scientists don't have a really good complete picture of how the first black holes formed not long after the Big Bang 13.8 billion years ago. Early observations, including by the James Webb Space Telescope, have shown astronomers that supermassive black holes more than 1 billion times the mass of our Sun already existed at the centres of galaxies less than 1 billion years after the Big Bang. One of the study's authors, Alice Young from Stockholm University, says many of these objects appear to be far more massive than what people thought they could be at such an early time in the universe's history. And that suggests they must have formed directly from the collapse of massive clouds of gas. Alternatively, they must have somehow grown extremely quickly through multiple mergers of smaller stellar mass black holes. But once again, the time factor comes in there. Black holes play an important role in the life cycles of all galaxies, but there are major uncertainties in science's understanding of how galaxies evolve. In order to gain a complete picture of the link between galaxy and black hole evolution, the authors used Hubble to survey how many black holes they could count among a population of faint galaxies when the universe was just a few % of its current age. The initial observations of the survey region were then re-photographed by Hubble after several years. This allowed Young and colleagues to measure variations in the brightness of these galaxies, and these variations are a telltale sign of black hole development. The authors were able to identify far more black holes than previously found by other methods. The new observational results suggest that some black holes likely formed through the collapse of massive, pristine stars during the first billion years of cosmic time. These types of stars can only exist at very early timescales in the universe. That's because later generations of stars are polluted by the remnants of the early generations of stars that have already lived and died. Other alternatives for black hole formation include the previously mentioned collapsing gas clouds, mergers of stars in massive clusters, and primordial black holes that must have formed by physically speculative mechanisms in the first few seconds after the Big Bang. With this new information about black hole formation and population, more accurate models of galaxy formation can now be constructed. The formation mechanism of early black holes is an important part of the puzzle of galaxy evolution. Together with models of how black holes grow, galaxy evolution calculations can now be placed on a more physically motivated footing, with a more accurate scheme for how black holes are likely to have come into existence from collapsing massive stars. This is SpaceTime. Still to come, a new volcano discovered on Jupiter's moon Io, and physicists at CERN confirm the mass of the W boson. All that and more still to come on SpaceTime. Astronomers have discovered a new volcano on Jupiter's moon Io. Io is the innermost and second smallest of the 4 Galilean moons orbiting the gas giant planet. It's also the 4th largest moon in the solar system, and with a radius of 1,822 kilometres, is only slightly larger than the Earth's moon. Io has over 400 active volcanoes, making it the most geologically active object in the solar system. It has the highest density of any moon, the strongest surface gravity of any moon, and the lowest amount of water by atomic ratio of any known astronomical object in the solar system. Together with Ganymede, Callisto and Europa, it was discovered in 1610 by Galileo Galilei and named after the mythological character Io, a priestess of Hera who became one of Zeus's lovers. The discovery of the new Volcano was made during an analysis of the first close-up images of Io in over 25 years. They were captured by the Junocam instrument aboard NASA's Juno mission. As well as revealing the emergence of a fresh volcano, it also showed the volcano walls had multiple lava flows, with volcanic deposits covering an area of about 180 by 180 kilometres. The new volcano is located just south of Io's equator. Now, although Io is already covered in active volcanoes, images taken during NASA's Galileo mission back in 1997 didn't see a volcano in this particular region. The images show the eastern side of the volcano is stained a diffuse red. That's from sulphur that's been vented from the volcano into space and then fallen back onto Io's surface. On the western side, two dark streams of lava have erupted, each flowing for about 100 kilometres. At the furthest point of the flows, where the lava's pooled, the heat's caused the frozen material on the surface to vaporise, generating two overlapping grey circular deposits. The best Junocam image of this feature were taken back on February the 3rd at a distance of 2,530 kilometres. They were captured on the night side of Io, with the illumination coming only from Jupiter, reflecting sunlight. The encounter was one of 3 recent flybys of Io in 2023 and 2024, during which Junocam acquired around 20 close-up visible colour images. The mission observed a total of 9 plumes associated with active volcanic features on the Moon. Io is kept volcanically active because of the heat generated through friction that's generated in Io's interior by the constant gravitational tidal forces exhibited by Jupiter as well as the other companion moons, constantly pulling and crushing Io as it orbits around the solar system's largest planet. This is SpaceTime. Still to come, scientists at CERN confirm the mass of the W boson, and later in the science report, a new study has found that cats show signs of grief when fellow pets die. All that and more still to come on SpaceTime. Scientists at CERN, the European Organisation for Nuclear Research, have confirmed the mass of one of the fundamental forces of physics, the W boson. The new findings show the particle has a mass of 80,360.2 megaelectron volts, give or take 9.9 megaelectron volts. In particle physics, bosons are elementary force particles, with the W and Z bosons mediating the weak nuclear force which is responsible for radioactive decay. W bosons have either a positive or negative electric charge and are each other's antiparticles, while the Z boson is electrically neutral and is its own antiparticle. Their discovery in 1983 was pivotal in establishing the standard model of particle physics, the foundation stone of science's understanding of the universe. The new mass confirmation follows an unexpected measurement by the Collider detector at Fermilab in the United States 2 years ago. To test that discovery, physicists with the Compact Muon Solenoid or CMS detector on the world's largest atom smasher, the Large Hadron Collider at CERN below the Franco-Swiss border, undertook their own experiment using a new technique to make the most elaborate investigation of the W boson's mass to date. The new measurements follow nearly a decade of analysis consistent with predictions, and so put the multi-year-long mystery to rest. The analysis used some 300 million events collected during the 2016 run of the Large Hadron Collider, together with a further 4 billion simulated events. From this massive data set, the authors reconstructed and then measured the mass from more than 100 million W bosons. They found the W boson's mass of 80,360.2 plus or minus 9.9 megaelectron volts is consistent with the Standard Model's prediction of 80,357 plus or minus 6 megaelectron volts. And that's really important. You see, the entire universe is a delicate balancing act. So if the W boson's mass was different from what scientists expected, it would have suggested new particles or forces at play. One of the study's authors, Hattie McBride from the US Department of Energy's Fermi National Laboratory, says that precise understanding of the W boson's mass allows scientists to map the interplay of particles and forces, including the strength of the Higgs field, which gives particles their mass, and the electroweak, the merger of electromagnetism with the weak nuclear force. Since 1983, physicists on 10 different experiments have measured the W boson's mass. The CMS experiment was unique from other experiments which have made this measurement because of its compact design, its specialised sensors for fundamental particles called muons, and an extremely strong solenoid magnet that bends the trajectories of charged particles as they move through the detector. Importantly, it also allowed physicists to free themselves of the Z boson as their reference point. This new level of precision will allow scientists to tackle critical measurements, such as those involving the W, Z and Higgs bosons, with enhanced accuracy. This report from the European Organisation for Nuclear Research.
The W boson is one of the particles responsible for transmitting the weak interaction. It was discovered in 1983 at CERN by the UA1 and UA2 experiments on the SPS proton-antiproton collider, leading to a Nobel Prize for CERN's Carlo Rubbia and Simon van der Meer. So why are we still measuring the mass of the W boson after 40 years? Well, for two reasons. We want to know the mass very precisely, and measuring it precisely is actually very, very difficult. Our best description of particles and their interactions, the standard model of particle physics, is overconstrained. Now, what do I mean by that? Well, if I take a wheel and I measure its diameter and I measure its circumference, well then of course the circumference has to be equal to the diameter multiplied by pi. If it's not, then either I'm measuring wrong or this is not a wheel. And that's what we call an overconstrained system. The measurements cannot be just any two numbers. So you can imagine the standard model like a cube. We have all these parallel sides and we're trying to measure their lengths as precisely as possible by measuring masses of different particles, interaction strengths. And then at the end we're trying to see if it's still a cube. Because what if the ends don't meet? How could that be possible? Well, that's possible if there's a new theory, new particles, new interactions that we haven't taken into account. So this way it's possible to see a new theory without discovering any new particles, but just by checking that things in their current theory don't agree. But for that we need all the measurements to be very precise. Trying to measure the mass of the W boson is like trying to measure the length of a stick blindfolded and holding it with only one hand. As opposed to trying to measure the mass of the Z boson, the other particle that transmits the weak interaction, which is like trying to measure the length of a stick by holding it at both ends with both hands. Now, what do I mean by that? The Z boson decays into two muons. And these muons can be measured very precisely in a particle detector, and from this measurement we can establish the mass of the Z. Now the W boson decays into one muon and one neutrino. And the muon can be measured precisely, but the neutrino cannot. And so we currently know the mass of the Z boson with a precision about 7 times better than the mass of the W. So how do we measure the mass of the W then? Well, let me take as an example the method used by the CMS collaboration in the recent W measurements. Let's first look at the Z boson again. So for the Z, the measurement is quite simple. We take the momenta of the two muons from the decay of the Z, and from these two momenta we can calculate what's called the invariant mass of the two muon system. You can plot this invariant mass for many, many pairs of muons, and you'll get a peak at the mass of the Z boson. There's some subtleties here, but basically if you measure the momenta of the muons correctly, then the position of the peak is the mass of the Z boson, and that's it. Now for the W, we only have one muon. So you cannot make an invariant mass plot from just this one muon. So what if we just try to simply plot the momentum of this muon? So you're also going to see some peak-like structure, but interpreting that in terms of mass is much more complex. The position of this structure will change with mass, but you cannot simply read the mass of the plot. So what you have to do is simulate this momentum distribution for different values of the W mass, and then once you have the observed data, you can check which of these simulated plots matches your observation the closest, and that gives you the mass of the W. Now, the complication of this measurement is that it strongly depends on theory and on simulations. So we have to have very, very precise modeling of the physics processes happening in the proton-proton collisions in the Large Hadron Collider, and we have to have very precise modeling of the response of the particle detector. So state-of-the-art theoretical calculations and state-of-the-art simulation of the detector are critical for getting this measurement right. This really is one of the hardest precision measurements done in the Large Hadron Collider.
This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with the Science Report. Researchers say tea, red wine, berries and even dark chocolate could help reduce your risk of getting dementia. A report in the Journal of the American Medical Association found the link was higher among people who are generally at greater risk of developing the condition. It all centres around flavonoids. These are compounds already known for various health benefits. They're found in a range of fruits and vegetables, including berries and green leafy vegetables, as well as tea, red wine and chocolate. For their experiment, scientists looked at the diets of over 120,000 adults aged between 40 and 70 in the United Kingdom over nearly a decade. 882 participants went on to develop dementia during the study. The authors say those who consumed the highest amounts of flavonoid-rich foods, especially tea, red wine and berries, had the lowest risk of dementia, especially if they had the highest genetic risk of dementia, high blood pressure or depressive symptoms. Scientists have found as many as 50 critically endangered night parrots living in the far east of Western Australia's Pilbara region. The discovery, reported in the journal Wildlife Research, represents the largest known population of these birds anywhere in the world. The authors were using a type of acoustic recorder called a song meter. They found evidence of night parrots at 17 of the 31 sites they checked. They found that a key threat to the bird's habitat is fire, which occurs in the surrounding sandplain country roughly every 6 to 10 years. A new study has shown that cats show signs of grief when one of their fellow pets dies, even dogs. A report in the journal Applied Animal Behaviour Science found that while cats appear to carry an attitude of indifference and aloofness, it turns out that when a fellow household pet passes on, surviving cats show grief-like signs that are similar to those of dogs. Their findings are based on a study of 412 pet owners who were the current caregivers of a living cat, but who also had a dog or cat in the household that had recently passed away. In the weeks and months following the loss of their pet, caregivers reported altered behaviour in their surviving cats. These included increased vocalizations, time spent looking or sniffing for the deceased pet in their usual spot, and a decreased willingness to eat, sleep or play. And the more time the surviving cat spent with the deceased pet prior to death, the more likely they were to show immediate and long-term behavioural changes. Pet owners in the survey claimed their cats clearly showed temporary signs of confusion and fearfulness following the death of a companion dog or cat. These included time spent hiding or sniffing out the deceased pet's favourite spot. The findings align with a similar study in 2016, which found that in the 6 months after the death of a fellow pet, both cats and dogs increased their attention-seeking behaviours, such as the frequency and volume of their vocalizations, and they also wound up eating less. Semantics issued a new warning about an iPhone scam based around an SMS phishing campaign. With the details, we're joined by technology editor Alex Zaharov-Reutt from TechAdvice.life.
Scams are rife, and the bad guys are always trying to figure out ways to catch you unawares with messages that are sort of seem plausible, seem legit, seem real enough that they want you to have a sort of a knee-jerk reaction. And in this case, this is emails claiming that your iCloud storage is nearly full and that you can get a 50% reward bonus if you sign up now. But what happens is that of course, when you go to update your payment details, you're sent to a malicious site that's trying to steal your login details and your credit card information and other information. And so it's just yet another confidence scam. But in this case, for iPhone users who have iPhones and have iCloud, many people only have the 5 gigabytes, but then they upgrade to the 50 gig or the 200 gig or the 2 terabytes. And, if your space is running out, that means your photos aren't being backed up, the newest contact details. These details are not being backed up to the cloud, which is the whole purpose of having the cloud. If you lose your device, you want to get it all back nicely and easily. So people panic. They've got things happening. They're in a rush. The kids are screaming. They've got work pressures. And suddenly there's this email demanding immediate attention. And they click it. They enter their details. It all looks legit. And the next thing they know is they've given up their iCloud username and password. Not that that really means much, because you still then have to get 6-digit code on one of your other Apple devices. But your credit card details go through. And you might even then think, hey, you've got extra storage. But unless you go into your iCloud settings, in the settings menu of your various Apple devices and check, you won't know. So it's a confidence scam, and I have seen this one before. This is a new instance, but this has been tried. I've seen friends that have had these sort of messages before, and they've forwarded to me and asked me, is this real? And you sort of have a look, and you look at who the message is from, and you see funny fonts, and it just doesn't look right. So if you're ever unsure about these things, you can always contact Apple directly. In Australia, that's 133 622 133 MAC. People in other countries, you can go to apple.com in your area and find the local number and have a look at your iCloud storage settings in the settings of your Apple device. You'll see how much space you have left. If you can see that you've got plenty of space left, it was just a scam.
We need to talk about the NBN faster broadband.
Yeah, look, the leak has come out from someone deep within the NBN that by around April next year, it will be offering to the retail service providers, the companies that sell the internet to you directly, because NBN is the wholesaler, a 2 gigabit plan. Now, you'll need to be on fiber to the premises or one of the pay TV style cable connections that are still connected, but you can then get 2 gigabits. Now, that is 40 times faster than your 50 megabit plan, obviously 20 times faster than your 100 megabit plan, and 80 times faster than your 25 megabit plan, which is a much slower plan that some people, I still hear being advertised on the radio. Some companies offering it $39.95 a month for the first 6 months, and then the price goes up. They don't say what it is too. But there are still people on these older plans. But we need faster internet because everyone has multiple devices, phones, tablets, laptops, desktop, everything that's on Wi-Fi gets updates. And if you're downloading lots of streaming media, or you're doing Zoom calls, or all the rest, if multiple people are in the house are doing it at the same time, and you say only have 50 megabits, which a lot of people are still on, then everything can slow down. If you're on a faster plan, obviously everything is sped up. But the other side of the coin is you get usually faster upload speeds too, and that's important because every device is backing up to iCloud or Google Backup or Google Photos, and people are uploading things. When you talk on Zoom, the video that people are seeing of you is being uploaded, and the faster your upload speeds are, then the better chance they can see you nicely and clearly. So it's also important that if you have fiber to the premises, which is the fiber that people wanted right to their homes, if it's available in your area, at the moment, NBN is offering a free upgrade. I'm definitely considering it for where I am. I just haven't done it yet because I'm on another pre-NBN system that was more reliable. It almost never goes down. You hear of people with NBN outages. But if you get that, originally you had to go to a 250 megabit, 500 megabit or gigabit plan. And of course, by April next year, you'll be able to get 2 gigabits. But you had to upgrade from 100. You had to upgrade from your current plan. And there has been a lot of talk that NBN is getting rid of that. So you can still be on the same plan you're on now, like the 100 megabit plan, and not have to go to a faster plan, so the price should stay the same, but you're on nice, pristine fiber right to your house. So eventually they're not going to do that for free anymore. And so if it's in your area, you should definitely consider it.
That's Alex Zaharov-Reutt from TechAdvice.life. That's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.